Okay, so there's our title. Now let's draw our axes in there. Okay. Label each type of bird. So we're going to have zebra dove, mannequin, I'm guessing sparrow maybe.
Are we able to abbreviate that just for like
Yes, you can. That's probably a better idea. Let me erase this. Let's abbreviate. Because our chart's going to go on for a mile if we try doing it this way. Let's abbreviate. What we may want to do is write our abbreviations up here. So if we're looking back at the chart, we know. Like zebra dove, maybe we want to say ZD. Mannequin, sparrow, MS, P for plover, and then BO for barn owl. So, zebra dove, mannequin, sparrow, plover, and barn owl. So these are our species down here. Now, I can't write sideways, so I'm just going to write out here frequencies. What's our highest frequency that we see in the table?
on the table?
Yep. What's the value?
Just for takeoff?
49 for takeoff, yep. So I'm going to, just for round numbers, I'm going to say 50 up here. And then what would probably be a good scale to count by? Tens. So to the best of my ability, I'm going to try to break this into 5 even chunks. 10, 20, 30, 40. Close enough. Okay, and then we go and we actually draw our shapes in here. Or draw our bars. I'm saying shapes because I'm just going to draw a rectangle. Zebra doves had about 49, so I'm going to come just below the 50. I really need to resize that some. There we go. There's my zebra doves. For the mannequin sparrow, we had 33. So just above the 33. Above the 30, I should say. For the plover, we had 29. So not much lower. And then for the barn owls, we had 6. So barely any barn owls. Okay, there's our graph. Questions on drawing the graph? Okay. We're going to lose our table, but y'all have it on y'all's paper, so we'll be good. So now they ask us to construct a relative frequency distribution table representing the bird species data for the landing runway. So what I would do is bring down my species column. And then you don't have to do this, but I would recommend bringing down the frequency column. Just the plain frequency column. And again, for sake of time and space, let's abbreviate. Species, zebra dove. On landing, the zebra dove was 68. Mannequin sparrow, they told us that was 82. Plover was 51. And barn owl was 39. Now, if we wanted this to look formal, since this is a table and like on the AP test, I would highly recommend writing those out. Don't abbreviate them because we want this to look like a formal table. So I would actually write these out if I were taking a test. Now we want to calculate relative frequency. So what do we need to do first before we can start calculating relative frequencies? Add them up, yes.
Are we doing the full total or just the landing?
Just the landing total. 240, yes. I'm going to put like a totals row down here. Okay, so for relative frequency for zebra doves, how would I calculate that? $68 divided by 240. So to 3 decimal places, what would that give me? 0.283. Okay. And then we'll go through each of these in a similar manner. So 82 divided by 240. What would that give you? 0.341. Okay. Yes, I'd prefer all around. So would it be 1 or a 2? 2? Okay. Okay, then next one, 51 divided by 240. 0.213. And then the last one, 0.163. Okay. And then let's add these up just to double check and make sure that we're on the right track. 1.001. Yep. So that 001 probably came from rounding error. There was some kind of rounding error in there. But we weren't way off, so that tells us we probably did it right. So questions on number 5 now? Yes. Oh, good catch. We do need a title. What should this title be? Well, what is this? Birds? That's what you were asking, right? The title? Okay. Good catch. I totally forgot. Birds found on landing runway. Good. Okay. Let me see if I can get the chat to come up, make sure there's no virtual questions. I can't read that. Can relative frequency be a fraction? Relative frequency could be a fraction, but usually we don't see it as a fraction because when we graph it, we want to use decimals. It could just get too messy, especially if in the future we'll start comparing stuff, and so it would start getting too messy. And then you might have 240 as the denominator on one, but 180 as the denominator on the other. The decimals just kind of even the playing field. Good question. Okay. Number, do you have a question, Will? Uh-huh. Let's see, hang on, let me go back. I'm on the wrong screen. Okay, so you're saying number 3. This part, or the sentence or two, commenting on the interesting features. Are you just asking like what am I looking for on that as far as comments go? So without knowing the whole problem, basically what you want to try to look for is what by far were for instance, what was the most common type of door and what was the least common type? What was that?
Yes, but what I was able to do is like coming to the order.
Type of door.
Oh, door.
Type of door. So what was the most common type of door and the least common type of door?
Okay, thank you.
You're welcome. And we'll talk about something, y'all are gonna laugh, but in chapter 3, we'll talk about something called cussing your graph. We'll learn to cuss our graph. Yes, sir. Okay, let's see how much we can get done of number 6 before the evil bell catches us. Okay, so they, without reading all the details, they've basically given us the wing weights of 2 different kinds of bats, fruit eaters and insect eaters. And A asks us to construct 2 dot plots that will allow you to easily compare the distributions. So if you want to write this on here, you can. These 2 dot plots allow you to compare distributions. So they are comparative dot plots. Comparative dot plots. So let's just get started. We're going to have to do 2 plots here. One for fruit eaters, one for for insect eaters. But they all are going to be under the same title, winged weight of bat. And then we need to draw our lines in here. Like I said, we're gonna have two of them. There's one. Down here. You two. The top one's going to be our fruit eaters. Bottom's going to be our insect eaters. Now, both of these have to have the same scale. So if we look, our smallest one on all the numbers combined is the 3.9, but our biggest looks like 114. So what we'll probably need to do is go from 0 to 120 to capture everything. So we're going to start down here at 0. And ultimately, we're going to end over here at 120. Now, you can pick your scale. I'm going to do 10s. So 10, 20, 30, 40.
What is it, 0 to 120?
Yes. I've not drawn the scale, but we'll go with it. Now, one thing you don't have to do is label each tick mark. What I would probably do is label every other one. 10, 20, 30, 40, 50, 60, 80, 90, 100, 40, 60. Okay. For the sake of time, I'm going to plot the insect eaters, walk y'all through those, and then the fruit eaters, I'm just going to place the points on the graph so we can get down to part B. Does that sound good? I'll walk y'all through the insect eaters. Fruit eaters, I'll just say, okay, this is where they should be. Okay, insect eaters, we have a 23.8. So I'm going to go between, kind of halfway between 20 and 30 almost, maybe a quarter of the way to the dot. And we have a 16.1. So find approximately 16.1 to the dot. 4.2. 3.9. I say that's not 3.9 dot. 4.2. 7.5. Yeah, these are getting kind of crowded in here. 3.5. I don't have one that way. And then another 3.9. So I stacked it. Those are really too crowded in there, but I don't have a smaller pen to use. Hopefully y'all kind of got the idea of it. Okay, so for the fruit eaters, I'm gonna, like I said, I'm gonna try and put the dots in there. There. 5 in between here. Try to squeeze 5 in there. If y'all saw me doing this, y'all probably laugh when I was making this key because I had a ruler out. I mean, I was measuring on this exactly, using centimeters to gauge everything like that. So that's just me. Okay, what do these tell us on the bottom? What are these numbers? They are labels. So we can't forget our axis labels. So that's part A. Part B asks us to write a short paragraph describing the features of the two plots. What do they tell you about the differences in the wing weights? So we can keep our plots up here. I'm not going to change screens to write the paragraph, and we're out of time. What are some observations based on these plots that you can make? They're both concentrated towards the lower end, but specifically, which one is smaller overall? Insect eaters. Insect eaters tend to have very low weights. What about the variability? Which one has more variability? The fruit. That's right. So the fruit eaters tend to have more variability. They're all over the place compared to the insect eaters. And then one that I kind of added, I mean, that all sounds good and all, but insect eaters only have how many observations? Yeah, 7 or 8. The fruit eaters have more. So who knows, if we would have collected more insect eaters, it may change the data. It might not, but it could. So that's kind of what I included in my description. And if y'all work on these more today, and you have questions before the end of school, you can come ask me. I'll be here. I'll also upload a key around 5 or 6 tonight, so then you can take the other answers. Yes.
Do we have anything aside from this for a homework dual?
Dual credit wise, if you've already turned in 1.1, you're good. Yes, sir. You too.